Hi pre-algebra students, it's Mrs. Tremblay. It's time for lesson 10A.3, solving special case equations. We're going to find out next year in Algebra 1 there's all kinds of special cases. This is your first introduction to it. You might find today's lesson hard to believe, but it is true, I promise you. Some equations do not always have one solution. Yes, you heard it. Sometimes you have more than one solution to an equation. They may have no solution also. So sometimes there is not a number that I could plug in that would make the equation true. That's called no solutions. So your two options today, things that are going to happen, you're either going to have no solution, meaning there's not an amount that will make the equation true, or you're going to have something called infinitely many solutions. Infinitely many solutions means no matter what number you plug in for the variable, it will work. So it could be any number. All right, can you see why these are special? I know, it seems crazy. All right, so I'm going to show you what they look like. Take a look at this first one. And basically, you might not recognize it right off the bat, but I'll show you how to recognize it once you solve it through. So usually with these, you'll go about your business and you'll be solving these like normal, and then all of a sudden it's like, wait a minute, this is weird. So I'm going to keep change. And this is a double-sided equation, right? And you learned when you have a double-sided equation that you add the opposite of one of the variable terms to each side, right? So the opposite of negative 4x would be positive 4x. So I would add 4x to each side, and this is where it gets weird. Negative 4x plus positive 4x is 0, right? So you're left with 3. On this side, you also have negative 4x plus positive 4x, which is also 0, and you're left with negative 7. So do you see how the variable term cancels itself out on both sides? Yeah. That's how you know it's a special case. When the variable term completely cancels out, it's gone. This is how you can tell what it is. At the end, you're left with 3 equals negative 7. Does 3 equal negative 7? Last time I checked, it did not. So if the variable term cancels itself out on both sides, and you're left with a statement that is not true, so I'm going to put this little slash through the equal sign. This means it's not equal to. If you end up with a statement that's not true, that means there are no solutions. Yes, write those words out. I know you want to know. No solutions to this. That means there is not a number I could plug in for x that would make this equation true. They can never be equal. This side can never equal that side. All right, on the flip side, take a look at this next one. And again, you won't recognize it right off the bat probably. You'll just be solving the equation like you normally would. And you'd say, oh, well, I want to cancel out this 3x. So I'm going to add a negative 3x to both sides. When you add negative 3x to positive 3x, it cancels, and you're left with negative 2. On this side, when you add 3x to negative 3x, it cancels out, and you're left with negative 2. Do you see how negative 2 does equal negative 2? It's the same number. That means there are infinitely many solutions. Don't abbreviate just yet. I want you to write the words out a couple of times so you'll remember them when you need to. So if, as you solve it, the variable term cancels out completely and you're left with a statement that is true, that means no matter what number you plug in for x, this side will equal this side. And I mean, think about it. I have 3x plus negative 2 and negative 2 plus 3x. Because of the commutative property, aren't those both really the same exact expression? So if x were 2 here and x were 2 here, I'd get the same amount. If this x was 10 and this x was 10, they would equal each other. Because it's the same exact expression on either side of the equation, no matter what you plug in for the variable, one side will equal the other. And that's what I mean by infinitely many. No matter what number you plug in for x, you're going to get a resulting expression that's true, or a resulting equation that's true. All right, let's try some of these with parentheses in them. And basically, if you see parentheses, that just means we need to distribute before we solve. So this 3 is right next to the parentheses. That means I want to take 3 and multiply it by the 2, which is 6. And I want to take 3 and multiply it by the 5x, which is 15x. And I'll bring down the rest of it. So right here, yep, we still have a double-sided equation. And with this double-sided equation, you choose one of the variable terms to cancel out. I'm going to cancel out this positive 15x by adding a negative 15x. 15x plus negative 15x is 0, and 0 plus 6 is 6. 15x plus negative 15x is 0. So you see how the x's are gone. They've canceled out. I'm left with 6 equals 0. Does 6 equal 0? No. So because this end statement is not true after the variable terms have canceled out, that means this equation has no solutions. No matter what I plug in for x, there's no way to make this statement true. And again, think about it. If I have 15x equals 15x, this one has an additional 6 being added. No matter what number I plug in for x, isn't this always going to be 6 more? No matter what. Yes. All right, last one of these. Draw your line, change your sign. Again, there are some parentheses in this one, so we want to distribute before we solve. So negative 2 times 4y is negative 8y. Negative 2 times 1 is negative 2. And I'm going to bring down the other side. All right, maybe you recognize right now, hey, that's the same exact expression on either side of this equation. This must be infinitely many. If you do recognize it at this point, you can write infinitely many solutions. I think most people are just going to go about their business of solving it. You won't focus on that right away. And you'll just be thinking, well, I'm going to cancel out this negative 8y by adding a positive 8y. And when you do that to each side, the y's end up canceling out here, and they cancel out there. The resulting expression is negative 2 equals negative 2. And we said, if the variable terms cancel out, and you end up with a true statement, that means that no matter what I plug in, it's going to be true. So this one has infinitely many solutions. So one more time, just to wrap it up, if you're solving an equation and the variable term ends up canceling itself out on both sides, so you're left with just a number equaling another number. If the statement is true, if you get two numbers that do equal each other, and it doesn't always have to be negative 2, it could be whatever. Like let's say I had 7 equals 7, 12 equals 12, 100 equals 100. If you end up with a resulting expression that's true, your answer is infinitely many. If after the variable terms cancel out, you end up with a statement that is not true, that means there are no solutions. No matter what you plug in, it's not going to work. You're all done. This one was short and sweet.